Hey there, let's talk about something you probably look at dozens of times a day, but maybe never really see. I'm talking about the clock. And it turns out there's some really cool math hiding in plain sight.
Okay, so let's set the scene. You look up at a clock, maybe one just like this one, and the time is exactly 7:20. Easy enough to read, right? But that specific time is the key to a really neat math puzzle. And here's the question I want to pose to you. What is the angle between the hour hand and the minute hand at 7:20? Now, your first instinct might be to do some quick math, but hang on, there's a catch. A really common trap that trips people up. So let's dig in and solve this thing properly.
All right, first things first. Before we can solve anything, we've got to understand the clock face itself. You see, it's not just a dial with numbers, it's a perfect geometric shape.
And that shape is, of course, a circle. The most fundamental thing you need to know about any circle is that a full trip around it is 360 degrees. That's our magic number, the foundation for everything we're about to do.
So you've got 360 degrees, and a clock has 12 hours, right? So what happens when you divide 360 by 12? You get 30. And that number, 30 degrees, is super important. What that means is that the little slice of the pie between any 2 hour marks, say from 12 to 1 or from 4 to 5, is exactly 30 degrees. You're going to want to keep that number in your back pocket. It is absolutely the key.
Okay, so we've got our 30-degree rule. Let's start with the easy part, figuring out exactly where that minute hand is pointing.
At 20 minutes past the hour, where is the minute hand? Well, it's pointing right at the 4. No mystery there. But we need to know its position in degrees. Remember our 30-degree rule. The minute hand is at the 4. So we just do a little multiplication. 4 times 30 degrees, and that gives us 120 degrees. That's its angle from the 12 at the top. All right? One hand figured out? Awesome. Okay, now for the tricky part, the hour hand. This is where that trap I mentioned comes in. It has a little secret that's easy to forget. And here it is, the big idea. The hour hand doesn't just jump from number to number. Nope. While that minute hand is sweeping around, the hour hand is slowly, steadily creeping its way from the 7 towards the 8. It never stops moving. So that's the real puzzle, isn't it? At 7:20, the hour hand isn't pointing at the 7. It's a little bit past it. But how much past? How can we figure out its exact position? The answer lies in thinking with fractions, or what we call proportions. The time is 7:20. 20 minutes have gone by in this hour. So what fraction of a full 60-minute hour is that? Well, 20 divided by 60 is 1/3. And that fraction, 1/3, is everything. Okay, let's piece this together. At 7 o'clock on the dot, the hour hand would be right on the 7. That's 7 times 30 degrees, which is 210 degrees from the top. But it's 7:20, right? We're 1/3 of the way through the hour. So that means the hour hand has also moved 1/3 of the way through that 30-degree space between the 7 and the 8. What's 1/3 of 30? It's 10. So we take our starting 210 degrees and add those 10 extra degrees of movement. Boom, the hour hand is at 220 degrees. And just like that, we've got it. We know the exact position of both hands. Now for the easy part. We just have to find the space between them. So let's just lay it all out. The big hour hand is at 220 degrees. The minute hand is at 120 degrees. Time to find the difference. Simple subtraction here. We take 220, subtract 120, and what are we left with? Our final answer, 100 degrees. There it is. The smaller angle between the hands at 7:20 is exactly 100 degrees. Pretty cool, right? It's just a beautiful mix of simple counting, a little bit of fractions, and some basic geometry. So why did we do all that? What's the point? Well, beyond just solving a fun puzzle, it's a great reminder that math isn't just in textbooks. It's literally everywhere, hiding in the most ordinary things. I mean, just think about what we just did. We had to use the idea of proportions, we used fractions, we measured angles, and we even had to think about the concept of continuous movement. All of that is packed into the simple act of reading a clock. It's an amazing little teaching tool, really. So hopefully the next time you check the time, you'll see a little bit more than just the numbers. And it leaves you wondering, doesn't it? What other elegant, beautiful math is just sitting there in our day-to-day lives, waiting for us to notice?